Welcome to this Java programming presentation. Today, we'll be solving a simple yet logical problem using a single-dimensional array. Our goal is to accept 20 different numbers from the user and find the sum of those which are divisible by 3 or 5. In this task, the user must enter 20 unique numbers. These numbers are stored in a single-dimensional array. We then identify and display all the numbers divisible by 3 or 5, and calculate their total sum. Let's walk through the algorithm. First, we start by declaring an array to hold 20 values. We ensure each new value is not a duplicate. Once 20 unique values are collected, we check each one for divisibility by 3 or 5. If the condition is met, we add the number to our running total. Finally, we display the qualifying numbers and their sum. We begin with the import statement to use the scanner class. Inside the main method, we declare the array and a counter variable. We prompt the user to enter 20 different numbers, preparing the loop that follows. This loop reads one number at a time using the scanner. We use a temporary variable called input to store each number. A Boolean flag, is duplicate, is initialized to false for each new entry. Now, let's take a closer look at how we prevent duplicate entries from being stored in the array. In this loop, we are comparing the newly entered input value with every number already stored in the array. We do this from index 0 up to count 1, because count keeps track of how many valid entries we've stored so far. If we find that numbers I equals input, it means the number has already been entered. So, we set is duplicate to true and use the break statement to exit the loop early, saving processing time. After checking for duplicates, we use an if statement. If is duplicate is false, it means the input is new and valid. We store it in the array at position count, and then increment count to move to the next empty slot. But if is duplicate is true, we skip the storage part and inform the user that this number has already been entered. They'll need to enter a different number to continue. This logic ensures that our array always contains 20 unique numbers, just as the problem demands. In this slide, we perform the main logic, identifying and summing numbers that are divisible by 3 or 5. We start by initializing a variable sum to 0. This variable will keep track of the total sum of the numbers that meet our condition. We then print a message to indicate that the following numbers in the output will be the ones divisible by 3 or 5. We loop through all 20 numbers stored in the array. For each number, we use the modulus operator % to check if the number is divisible by 3 or 5. If either condition is true, the number is printed on the screen, and we add it to sum using sum plus equals numbers I. This way, we keep track of all qualifying numbers and build the total sum simultaneously. After checking all the numbers, we print the final result, the sum of all numbers divisible by 3 or 5. This marks the completion of our logic. In this slide you will get the full program link which you can execute the entire program. Also, program link is available in the description box. Here is a table of variables used in our program. Numbers is the array for storing user inputs. Count keeps track of the number of unique entries. Input holds each new entry temporarily. is duplicate helps identify duplicates, and sum stores the total of divisible numbers. This is a sample run of the program. After entering 20 different values, the program prints all numbers divisible by 3 or 5 and then shows their sum. This confirms that our logic and implementation are working correctly. Let's recap the flow. We collected 20 different integers, avoided duplicates, and checked each one for divisibility by 3 or 5. The qualifying numbers were displayed, and their total sum was calculated and printed. To summarize, this program helps you practice arrays, conditional statements, and user input validation. It also reinforces the use of the modulus operator and structured coding. This is a practical example of applying fundamental Java concepts to solve real-world problems. Thanks for watching. Documentation containing question, algorithm, Java program, variable description table, VDT, sample output is also available in description box of this video. Don't forget to subscribe if you are using this for your school or college projects. Happy learning!